Implicit differentiation. We want to be able to calculate the derivative of a function implicitly. Implicit form simply means that the variables are embedded within the equation. Explicit, the direct opposite, is where in a function or an equation, one variable is expressed singly. Look at the examples for implicit and explicit forms. Here, for the implicit xy equal to 1, you could express y explicitly as a function of x by dividing both sides by x, and you get y equal to 1 over x. And then taking the derivative. This is the derivative explicitly, but we're going to talk about taking the derivative implicitly. Look at one of my favorite examples, x squared plus y squared equal to 1, a circle. Y is expressed implicitly. Here you can take that same equation, solve for y. Y is equal to the square root of 1 minus x squared, where x is on the interval from -1 to 1. And here y is said to be expressed explicitly. Now, how do you calculate the derivative with respect to y implicitly? Well, there's some guidelines from the textbook. We'll apply that. I think one of the key notes here that I can surmise is that when you're taking the derivative implicitly, just apply the chain rule on y, and then from there just isolate dy over dx. Let's look at some examples. So here we calculate the derivative implicitly. We're looking for dy over dx. We take the derivative, we get 2x plus 2y. Apply the chain rule on y squared, so it's 2y times the derivative of y, we just call that y prime, is equal to the derivative of a constant is 0. And so here we isolate y prime. Well, notice that you have 2y times y prime is equal to negative 2x. Divide both sides by 2y, and so we get y prime is equal to negative x over y. So it's nothing to that. Secondly, take the derivative here, we get 1/2 x to the 1/2 minus 1, so that's negative 1/2 plus 1/2 times y to the negative 1/2 times the derivative of y, that's y prime, equal to 0. Multiply both sides by 2, just to simplify that. Notice that this is 1 over the square root of x plus y prime all over the square root of y is equal to 0. Subtract 1 over x squared to both sides, so we have y prime over the square root of y is equal to negative 1 over the square root of x. Multiply both sides by the square root of y, and you get the answer that y prime is equal to negative times the square root of y over x. Look at this problem. Take the derivative implicitly, so we get 3x squared. Now, if you're asked to take the derivative implicitly with respect to x and y, then this would be 3x squared times x prime, or dx over dy. But here we're taking the derivative implicitly with respect to y. So minus, apply the chain rule, apply the product rule, take the derivative of the first, which is 1 times y. Then it's plus, but this minus is going to trump that through the distributive property. So it's minus the first times the derivative of the second, which is y prime, plus the derivative of y squared, which is 2y times y prime, equal to 0. I'm going to do a couple things at once. I'm going to get the y prime by itself, that is just factored from the terms that it's associated with, this 2y minus x. Get the other terms on the other side. That's y minus 3x squared, x squared. Looks like a 2 almost. And now we can write y prime is equal to y minus 3x squared over 2y minus x. And you know that y prime is the same thing as saying dy over dx, right? This problem kind of similar to the previous one, but a little bit more involved. So this is 3x squared minus, take the derivative of the first, that's 6x times the second, minus 3x squared, the first, times the derivative of the second, that's y prime, plus use the product rule on this expression. This is 2 times y squared plus the first times the derivative of the second, which is 2x times 2y times y prime, right? So this is 2 times 2. We get 4x times y prime equal to 0. I'm going to collect the terms associated with y prime. That's 4xy minus 3x squared equal to 6xy minus 3x squared. Now divide everything by this term associated with y prime. So y prime is equal to 6xy minus 3x squared all over 4xy minus 3x squared. Attempted by the enemy to do some type of cancellation, but we cannot. Unlike terms. Let's simplify this. This is sine x is equal to x plus x times tan y. Now we take the derivative everywhere. This gives us cosine x that's equal to 1 plus, use the product rule. The derivative of x is 1 times the second tan y plus the first times the derivative of the second secant square y times y prime. So we're going to get the y prime by itself. So I'm going to subtract the 1 and the tan y on both sides. So we get cosine x minus 1 minus tan y is equal to x secant square y times y prime. Now the y prime is equal to this left side divided by x secant square y. So cosine x minus 1 minus tan y all over x secant square y. That's all I have for you folks. Thank you.